In lesson 9.5, you will write and graph equations of hyperbolas. A hyperbola is the set of all points xy such that the difference of the distances from xy to two distinct fixed points called foci is constant. So our hyperbola has a center and it has vertices on a transverse axis. The vertices are on either side of the center on that transverse axis, and they're a distance of a units from the center. So this vertex is located at a0, and this vertex is located at negative a0. Now there is a distance of b units on either side of the center on an axis perpendicular to the transverse axis, but not like the ellipse. These points and that axis perpendicular to the transverse axis have no special name, but they do help us build a box through those points and the vertices, and we can use this box to locate the asymptotes of the hyperbola. The asymptotes travel through the corners of this box. There's two asymptotes that travel through the corners of the box and through the center of the hyperbola. Now when I draw the branches of the hyperbola, they travel through the vertices and they follow those asymptotes. Those are the branches of this hyperbola with a horizontal transverse axis. Okay, now there are foci located inside those branches, and those foci are a distance of c units from the center. So this foci is located at c0, and this focus is located at negative c0. Now any point by definition, any point xy on this hyperbola, the distance to those foci, the difference of those distances from those foci is always constant. That's what forms the branches of the hyperbola. Those distances, again, the difference of those distances is constant. In example 1, we're going to graph 9y squared minus 16x squared equals 144. We'll identify the vertices, foci, and asymptotes for this hyperbola. And I recognize it as a hyperbola because one of the squared terms is negative. I'd want to get this equation in standard form, which means I want 1 on the right-hand side. So I'm going to divide every term in this equation by 144. I'm dividing both sides by 144, distributing on the left. So every term is divided by 144. And when I simplify, I know 9 goes into 144 16 times. So I get y squared over 16 minus, and 16 goes into 144 then 9 times. So I get minus x squared over 9 equals 1. And now I can write this equation one more time showing my a value and b value. So I can write 16 as 4 squared and 9 is 3 squared. Okay, because the x term is negative, this hyperbola is going to have a vertical transverse axis. When y squared is negative, like on the previous page, we have a horizontal transverse axis. So we have a vertical transverse axis. Our a value is underneath the positive term, so our a value is 4. Our b value is underneath the negative term, so our b value is 3. Now I know the center is 0, 0, because both h and k are 0 in this equation. And I know that my vertices are located a units on that, from the center on that vertical axis. So I'm going to go up 4 units to locate one vertex, and I'm going to go down 4 units to locate the other vertex. Okay, that b value, that distance of b units, is left and right of the center. And remember, that's going to help me form a box. A box that I can draw asymptotes through the corners of and through the center. And then I can draw the branches of the hyperbola traveling through the vertices on this vertical transverse axis and following those asymptotes. So these branches are kind of parabolic in shape, shaped like parabolas. Okay, now I need the foci, and the foci are going to be a distance of c units from the center on this vertical transverse axis. So I need to find c, and the equation to find c for a hyperbola is c squared equals a squared plus b squared. So c is going to equal the square root of a squared, which is 4 squared or 16, plus b squared, which is 3 squared or 9. Now I know I would get 2 solutions, plus or minus, but c is a distance, so I'm only worried about the positive value that I get. So I'm getting the square root of 25, which is 5. So c is equal to 5. So up 5 units from the center, I'm going to locate one focus, and down 5 units from the center, I'll locate the other focus. Okay, now to identify the vertices, they were at 0, 4, and 0, negative 4 on that vertical transverse axis. The foci are at 0, 5, and 0, negative 5. And the asymptotes that I sketched through the corners of the box and through the center have a form y equals plus or minus. The slope is a over b, so that would be 4 over 3, or 4/3 x. So one asymptote is y equals 4/3 x, and the other asymptote is y equals negative 4/3 x. In example 2, we want to write the standard form of the equation of the hyperbola with foci at 0, negative 5, and 0, 5, and vertices at 0, negative 3, and 0, 3. So I'm going to make a sketch of this hyperbola in order to determine my transverse axes, whether it's horizontal or vertical. My foci are at 0, 5, and 0, negative 5. My vertices are at 0, negative 3, and 0, positive 3. And I know that the center has to be halfway between those vertices and those foci, so the center is 0, 0. So because it has a vertical transverse axis, that's where the vertices and foci are located, the equation is going to be of the form y squared over a squared minus x squared over b squared equals 1. So I need to know my a and b values. Well, I know a is the distance of the vertices from the center, and that distance is 3 units. I know c because that's the distance that the foci are from the center, 5 units. But what I don't know is b. I don't know the distance that those points are from the center that will allow me to build this box for this hyperbola and draw those asymptotes through the corners of the box and the center and then sketch the branches of this hyperbola traveling through the vertices and following those asymptotes. So I need to find b, because in order to write this equation I need both a and b. So I'll use that equation, c squared equals a squared plus b squared, in order to find b. And for c I'm going to put 5, and for a I'll put 3, and I'll solve this equation for b. So I'm going to find out that b squared is equal to 5 squared, which is 25, take away 3 squared, which is 9, or b squared is equal to 16, and taking the square root of both sides, I find out that b is equal to plus or minus the square root of 16, which is 4. But because b is a distance, I only want to note the positive value b, so b is equal to 4. And now that I know a and b, I can write the equation. Y squared over a squared, and a is 3, so I've got 3 squared in the denominator, minus x squared over b squared, and b is 4, equals 1. So I'll clean this up and leave that first denominator as 9, and leave that second denominator in this equation as 16. So there's the equation of our hyperbola with a vertical transverse axis. Include with your notes of this video guided practice problems 2, 3, and 4 on page 644 of your textbook.